Howdy folks, welcome back. So in this video I'm just going to quick go through the practice test 2 and again just kind of walk you through how I would go about solving the problems. Again, I recognize it's by no means the only way, and in some cases it might not be the way that works best for you, but again this is just how I go about solving the different problems there. Again, you can find this practice test on the assignments page on the Pearson website, so where you generally find the homework. You should be able to scroll down and you should see practice test 2 there. So let's go ahead and get started here. All right, so this test is mainly focused on chapter 2. So chapter 2 is where we mainly talked about matrices. So most of the questions are going to be dealing with matrices here. All right, so the first one here is just kind of writing out the matrix corresponding to a system of linear equations. So here we have a system of equations, and then we're asked to write the matrix that corresponds to that. All right, so to rewrite this system of equations as a matrix, we're just going to focus on the coefficients. So here we have -8, -9, 7, and then generally do a bar, and then to the right of the bar, that's where we include the answer. So the bar kind of takes the place of our equal sign there. All right, so then we have 2, -6, 5, and 7, and we have 0x, 1y, -4z, and -5. So yeah, so it's just asking for the matrix corresponding to that system of equations. All right, so once you have that matrix written down, you go through a process known as pivoting. So you do multiple pivots on the matrix, and eventually you end up with what's known as the row reduced echelon form. So that's what this RREF stands for. So row reduced echelon form. So that means that I have ones along my diagonal as far as I can, and zeros everywhere else in those columns. All right. So yeah, so eventually when you get to that point, you have your solution. So your solution you can just read straight across. So against the column, so we have x, y, and z. So in this case, my solution is x equals 4, y equals 3, and z equals 0. So in this case, there's a single solution. So we have x equals 4, y equals 3, and z equals 0. Oh. Okay, so yeah, so it's asking us for not only the answer, but also the system of equations there. So again, these are your coefficients, and then the farthest right-hand column is what they equal. So we have 11x plus 2y plus 4z. We have 6x plus 1y plus 2z equals 27. And we have negative 3x plus 0y minus 1z equals negative 12. All right. So again, how you get from the first form that we talked about, to the other is by doing a process known as pivoting. All right, so I'll just go ahead and start off just by writing this matrix down here. All right. So to pivot about an element, that means that I want to get a 1 for this circled element here, and I want to get a 0 everywhere else in that column. So everywhere else in this third column, I want the other two entries to be 0. So to start off, I'm just going to divide every single one of my entries in row 2 by that number. So by the value that I'm pivoting. So I'm just going to divide everything in the second row by 2. All right, and then we have -1/2 over 2. I'm just going to leave it as fractions for right now. 1 and 1. We have 5, 0, 2, and 1. All right, so we want to get a 1 as this entry here, and then we want to get a 0 everywhere else. So in this next step, my second row is going to stay as it is. All right, and then I want to get a 0 as my entry here. So to do that, I'm going to take 4 times row 2, and I'm going to add it to row 1. Sorry, negative 4. Because when I take negative 4 times 1, that's going to be negative 4, plus 4 is going to be 0. All right, so when I take negative 4 times negative 1/2 here, so that's going to be a positive 2, because negative times negative gets me positive, and 1/2 of 4 is 2. So I have 2 plus 7 is going to be 9. Negative 4 times 5 over 2. All right, so that's going to be negative 10 plus 5 is going to be negative 5. Yeah, so we have negative 4 times 5 over 2 plus 5. And finally, we have negative, or not quite finally, penultimately, I guess. We have negative 4 times 1 is going to be negative 4, plus 4 is going to be 0. And negative 4 times 1, now finally, it's going to be negative 4 plus 6 is going to be 2. So that's how I get a 0 in my first row. And then to get a 0 in the third row here, again, I need to ask myself, what do I need to add to 2 in order to get 0? So in this case, that's going to be negative 2. So we have negative 2 times row 2 plus row 3. All right, so we have negative 2 times row 2, which is going to be negative 1/2 for the first one here. Then we add 5, so that's going to be negative 1 plus, so that's going to be, yeah, positive 1 plus 5 would be 6. All right, negative 2 times 5 over 2 is going to be negative 5 plus 0 is going to be negative 5. Negative 2 times 1 is going to be negative 2, plus a 2 is going to be 0. And negative 2 times 1 is going to be negative 2, plus a negative 1 is going to be negative 1. So we have 9, negative 5, 0, negative 1/2, 5 over 2, 1, and 6, negative 5, and 0. So yeah, so again, when solving a system of equations, you want to pivot about the entries along your main diagonal, so you end up with 1s along your diagonal and 0s everywhere else, and that will lead you to a case in the previous question. All right. So yeah, so in some cases, you're not going to be able to get 1s along your diagonal and 0s everywhere else. So in those cases, you either have an infinite number of solutions or you have no solution there. So yeah, so in this case, we have an infinite number of solutions. So yeah, so in this case, my matrix is going to be 3, negative 1, 1, negative 2. Again, this is the matrix corresponding to A here. And 3. So yeah, so most of the time when you have more variables than you have equations, that's a lot of times where you end up with where you have an infinite number of solutions there. All right. So my final So yeah, so again, what these represent here, so this first row represents the equation x1 plus 2x3 equals 1. And my second row here corresponds to the equation x2 plus 5x3 equals 5. All right, so you're going to use the ones that don't correspond to where you have ones on the diagonal. Those are going to be your quote-unquote wild cards. So in this case, you're going to have x3. And then we can use these values for x3 to find particular solutions for x1 and x2. So to solve for x1, you can subtract 2x3 from each side. So we have 1 minus 2x3 for x1 there. And then for x2, we can solve this for x2, so we can subtract the 5x3 from each side. So we have 5 minus 5x3. So in this case, there are infinitely many solutions. So again, x3 is our wild card, so x3 can be any number. And then x1 is going to be 1, so negative 2x3, and x2 is going to be 5, so negative 5x3. All right, and then we have 9, 29, 4, 19. Again, this is just translating from the matrix to the system here. 8, 1, 3, negative 2. All right, so if you end up with a system or a matrix where you have all zeros in one row except for the final entry is a non-zero number, that's when you have no solution. Because again, this corresponds to the matrix, to the system 0x1 plus 0x2 plus 0x3, which there's no values of x1, x2, or x3. But if I multiply each of those times 0 and add them all together, get me a positive 1. Again, if you multiply anything times 0, you end up with 0. And if you add a bunch of zeros together, you're going to end up with 0. So in this case, there is no solution. All right. Next couple questions here are dealing with operations with matrices. All right. So to find the sum of two matrices, you're just going to add the corresponding entries. So here we have 3 plus a negative 8. It's going to be a negative 5. Negative 3 plus 6 is going to be 6. 2 plus a negative 3 is going to be negative 1. And 0 plus 2 is going to be 2. So in this case, we're going to have a 2 by 2 matrix. And we have negative 5, 6, negative 1, 2. All right, likewise, when subtracting, you're just going to subtract the corresponding entries. So here we have 8 minus 1 is going to be 7. Negative 3 minus a negative 8, so that's going to turn into negative 3 plus 8, so that's going to be 5. 4 thirds minus 1 third, so that's going to be 3 thirds, which 3 thirds is going to be 1. Negative 5 minus a negative 5, so that's going to be negative 5 plus 5, so that's going to be in 0. Negative 6 minus 6 is also going to end up being 0. And then we have negative 2 minus 0 is going to be negative 2. So in this case, we have 3 rows, 2 columns, 7, 5, 1, 0, 0, negative 2. All right, in this case, we have multiplication. All right, so to find the product of two matrices, we're just going to multiply across the rows of one matrix down the columns of my second matrix. So I'm just going to take the product of each corresponding entry, and I'm just going to add all those products together. All right, so to find my first entry in the first row, first column, I'm just going to march across the first row of my first matrix down the first column of my second matrix. So we have negative 3 times negative 3, so we're just going to multiply the corresponding entries here, plus negative 1 times negative 1. All right, so then for the next column, I'm going to use, so this is the first row, second column, so I'm going to use the first row of my first matrix again, and the second column of my second matrix. So we have negative 3 times 5 plus negative 1 times 3. All right, and then for the second row, so the second row, first column, we're going to take our second row of our first matrix, again, first column of my second matrix. So we have 0 times negative 3 plus negative 5 times negative 1. All right, and finally, for my second row, second column, I'm going to use the second row, second column, so we have 0 times 5 plus negative 5 times 3. All right, so we have negative 3 times negative 3 is going to be positive 9. Negative 1 times negative 1 is going to be 1. So we have 9 plus 1 is going to be 10. Negative 3 times 5 is going to be negative 15. Negative 1 times 3 is going to be negative 3. So we have negative 15 plus a negative 3. It's going to be negative 18. 0 times 3 is going to be 0. Negative 5 times negative 1 is going to be positive 5. So 0 plus 5 is going to be 5. And 0 times 5 is going to be 0. And we have negative 3, or negative 5, sorry, times 3 is going to be negative 15. So you have 0 plus a negative 15 is going to be negative 15. And negative 18, 5, negative 15. All right. So here I have another example of where we're finding the product of two matrices. So in this case, we have a 3 by 3, and here we have a 3 by 1. So again, in order to find the product, the previous one was a square matrix, so you can always find the product of two square matrices that are the same dimension. So in order to find the product, these two inside dimensions need to be the same. So this tells me that the product of this, and then my final matrix is going to have the dimensions of my two outer dimensions. So in this case, my final product is going to consist of 3 rows and a single column. All right, so to find those entries, again, you're just going to march across the rows of your first one and march down the column of your second matrix here. Again, taking the product of each of your corresponding entries and then find the sum of all those products. All right, this is a 0. Just wanted to make sure it was a 0, not a 6. All right, so for my first row here, I'm going to march across the first row of my first matrix and down the column of my second matrix. So we have 4 times 4 plus 1 times 4 plus 0 times negative 2. All right, so then for my second row, I'm going to move down to the second row here. So you have negative 2 times 4 plus 0 times 4 plus 9 times negative 2. And finally, for the third row here, we're going to use the third row, and again, the column here. So we have negative 6 times 4 plus negative 5 times 4 plus negative 9 times negative 2. All right. So yeah, so now just performing the arithmetic here. So we have 4 times 4 plus 1 times 4 plus 0 times negative 2. So that gets us 20 for the first row. We have negative 2 times 4 plus 0 times 4 plus 9 times negative 2. It's going to be negative 26. And finally, we have negative 6 times 4 plus negative 5 times 4 plus negative 9 times negative 2. That's also going to be negative 26. So we have 3 rows and a single column. So we have 20, negative 26, and negative 26. All right. All right. So now we have, so we talked about matrix inverses. So if you have a matrix inverse, you can rewrite a system of equations as a matrix equation. So we have AX equals B, where A is the matrix of your coefficients, X is going to be the matrix of your variables, and then B is going to be the matrix consisting of the entries on the right-hand side of the equal sign. All right, so then to solve this, we're trying to solve for X most of the time here. We can just take the inverse of my coefficient matrix and multiply it by my matrix B. All right, so in this case, my A, so the matrix corresponding to this system of equations, is given here, and then we're given that the inverse is my second matrix given here. So A inverse is going to be the matrix 5, negative 1, negative 1, negative 2, 1, 0, negative 2, 0, 1. All right, so then to solve for my matrix X, I'm just going to take the inverse. So that's going to be 5, -2, -2, -1, 1, 0, and -1, 0, 1 times my matrix B, which again, the matrix B is consisting of the entries on the right-hand side of your equal sign. So you have -31, -38, and -35. All right, so again, just marching across the road down the column. So we have 5 times -31 plus -2 times -38 plus -2 times -35. All right, so then for the second row here, again, we move to the second row. So you have -1 times -31 plus 1 times -38 plus 0 times -35. And finally, for the third row, take -1 times -31 plus 0 times -38 plus 1 times -35. So you have 5 times -31 plus -2 times -38 plus -2 times -35. So you have -9. You have -1 times -31 plus 1 times -38 plus 0 times -35. So we have -7. And finally, here we have -1 times -31 plus 0 times -38 plus 1 times -35. We have -4. So in this case, we have -9, -7, -4. So again, the first row corresponds to my X, second row corresponds to Y, and the third row corresponds to Z. And again, if you're curious as to whether you have the right answer or not, with these problems, it's really easy to check. You just go back and plug in -9 in for X, -7 in for Y, and -4 in for Z in each of your equations up here, and you should end up with a true statement all across the board. All right. And finally here, we have what we finished in class today, so dealing with input-output matrices. All right, so the first part here is just dealing with setting up the problem. And then we'll get to solving the problem on here. All right. All right, so here we have a simplified economy. It consists of two sectors, transportation and energy. So for each dollar worth of output, the transportation sector requires 28 cents worth of input from the transportation sector and 36 cents worth of input from the energy sector. And for each dollar worth of output, the energy sector requires 23 cents from the transportation sector and 31 cents from the energy sector. All right, so again, we have our to produce, each of these, and then from is the rows. All right, so for each dollar worth of production within the transportation sector, I require 28 cents from the transportation and 36 cents from the energy. And then for the energy sector, For each dollar worth of output, I require 23 cents from the transportation sector and 31 cents from the energy sector. All right, so that is my matrix A. All right. So again, our main fundamental equation here is we have I minus A times X equals D. All right. So again, this means that my solution, so my X, which is my production matrix, is going to be I minus A inverse times D. All right. So the first step is I need to figure out what this I minus A inverse. And before I do that, I have to figure out what I minus A is. Again, I is my identity matrix. So that's going to be the matrix consisting of ones along my diagonal, zeros everywhere else, minus my matrix A, which is 0.28, 0.23, 0.36, and 0.31. All right, so again, you just subtract corresponding entries here. So we have 1 minus 0.28. It's going to be 0.72. 0 minus 23 is going to be negative 0.23. 0 minus 0.36 is going to be negative 0.36. And finally, 1 minus 0.31 is going to be 0.69. So that's my I minus A. So then I need to figure out I minus A inverse. All right. So the first step here is I need to figure out my determinant of my matrix I minus A. So the determinant is going to be what I get when I take the product of the main diagonal entries minus the product of my secondary diagonal entries. So you have negative 0.23 and negative 0.36. So 2.69 minus negative 0.23 times negative 0.36. So we have 0.414. All right, so then my inverse. So to find your inverse of a 2 by 2, you're just going to swap the entries along your main diagonal. So I'm just going to swap these entries along my main diagonal here. Oh, should be using this one here. Yep. Sorry. All right. So we have, so we're going to swap these entries along my diagonal here. So the 0.72 and the 0.69. So 0.69, 0.72. And then you're going to change the signs of the entries along your secondary diagonal. So you swap the entries along your main diagonal, change the signs along your secondary diagonal. So that's going to be 0.23 and 0.36. All right, and then once you have performed all the switching and swapping, you're just going to divide each of these numbers by your determinant. All right. So, yeah, so I'm just going to round to 2 decimal places here. Six 414.87 and 0.72 divided by 0.414 is 1.74. All right, so that is my I minus A inverse. One 1.67, 0.56, 0.87, and 1.74. All right. So then to find how much I need to produce, so my X, I need to take this I minus A inverse that I just found here and multiply it by my final demand. So in this case, my demand matrix, so my matrix D, in this case, the sector, so the demand is $4 billion from transportation and $5 billion from the energy sector. All right, so then my production matrix is going to be this I minus A inverse. All right. So we have 1.67 times 4 plus 0.56 times 5. So we have 9.48 for the first one there. And then for my second row, again, just going to march across the second row down my column. So we have 0.87 times 4 plus 1.74 times 5. So we have 12.18. And these are both in units of billions of dollars. The transportation sector should produce 9.48. And the energy sector should produce 12.18 billion. All right, so then to find out how much of the transportation output and energy output is used to meet the internal consumption, you're just going to take your totals that you would need and subtract your demand because everything else is being used in production there. All right, so for the transportation, we have 9.48 minus my 4 billion for demand, so 9.48 minus 4 is going to be 5.48. And then we're going to do a similar thing for the energy. So we have 12.18 for the total production, and the demand is 5 billion, so we have 12.18 minus 5 is going to be 7.18. All right, so hopefully that all worked. So let's see how we did here. Uh-oh. What do we do here? Did I just add wrong? Oh, that's embarrassing. Yeah, it looks like I just added wrong. All right. Yeah. -3 plus 6 should be +3, not +6. All right. And I also subtracted wrong. My goodness. So -6 minus 6 should be -12. Yep. So 6s, they got to me today. All right. I think that was all the ones that I got wrong. So yeah, so again, just beware. Watch your arithmetic. But yeah. All right, hopefully you found this helpful. Have a lovely day, and I'll talk to you all later. Bye now.